Hey guys, welcome to this page of the notes. And again, what we're doing is we're working on situations where we could potentially have the ambiguous case. Now, how do I know if it's going to be the ambiguous case or not? Well, that's based on the information that we've been given, right? Taking a look at the diagram, the fact that I've given you the measure of angle A, I've also given you the length of side A is 21, and you've been given another side, so you have two sides and an angle. That means that you have side angle. And again, going back to the very first page of the notes where we talked about the information you would have to be given, right? If you're given side angle, the law of sines will work. The problem with this one is it could potentially be the ambiguous case. And so that's what we've got to check for. We've got to check and see, do I have the ambiguous case where there's actually two possible triangles based on the information I've been given. The only way that I'll know if it's the ambiguous case is if we find the value of h. So we start by finding h. You say, hang on a second, there is no h in my problem. That's fine, draw your own. Remember, h is just going to be the height of that triangle. And again, right, that means that h is the opposite side from the measure of the angle 25. So this is opposite. If this is the angle 25, that makes 18 the hypotenuse. And do I have something that will allow me to find, right, the ratio of the opposite over the hypotenuse based on the measure and acute angle? And just like in the last problem, sine will do that for us. So the sine of A is equal to the opposite over the hypotenuse, which means the sine of 25 degrees is equal to h over 18. H is equal to 18 times the sine of 25 degrees. Again, easy algebra problem. You just multiply the 18 to the other side. At this point, it's a calculator problem. Don't fat finger something on your calculator, and you wind up with h is equal to 7.6. All right, now I take a look at the information I've been given. H is equal to 7.6, A is equal to 21, and B is equal to 18. Okay, so now what do I know? Well, I take a look at those numbers and look at that. A is greater than B because 21 is greater than 18. So now I got to take a look and see which case is this. Again, I'll give you the table that we looked at that describes the possible cases. So let's go back to that table, which is right here. And I had A was greater than B. No. Nope. No. There it is. A is greater than B, which means there's only one possible triangle. This is not the ambiguous case. This problem is going to be just like the ones we've already done in this section. We'll just simply use the law of sines to solve for everything we don't know. So let's go back to our problem. We know that there's only one possibility. And this is it. The only possibility is this guy right here. There's C. This is 18. This guy was 25 degrees. And my only possibility is this right here. There's side A. It's 21. And yeah, that's what I know. That's my only possibility. There's only one possible case here. So now we're going to go ahead and solve for the stuff that we don't know. This will be side C down here. This was angle A. This was angle B. All right, so I've got my diagram labeled. I've got my diagram drawn. Here we go. Let's do the law of sines. Okay, I know angle A and I know side A. So sine of A over A. What else do I know? Well, I know side B, which means, you bet, we're going to be solving for angle B. So the sine of angle B over B, and we plug in what we know. Here we go. Sine of 25 degrees over 21 is equal to the sine of B. I don't know, we're going to solve for that, and that's over 18. Again, we've now done this I believe at this point, this is the third time now where we have solved for the measure of an angle. I think we can probably do it all in one step. I'm going to multiply the 18 to the other side. It'll go straight into the numerator. So then I will have the sine of b, right? The sine of b will be equal to all of this. But in order to solve for the measure of the angle, I have to take the inverse sine. So the measure of angle b will be equal to the inverse sine of 18 times, right? 18 because I had to multiply the 18 to the other side. So 18 times the sine of 25 degrees all over 21. Again, this is a calculator problem. Do it piece by piece. Sine of 25, multiply that by 18, divide that by 21. You're going to get a number. You'll do the inverse sine of whatever that number is. Don't fat finger something on your calculator. And you wind up with the measure of angle B is equal to 21.2 degrees. All right, great. That's the measure of angle B. I've got some other stuff to solve for, though. 21.2 degrees. I still don't know the value of the measure of angle C, and I don't know the length of side C. Let's go ahead and find those. Here we go. First, the triangle sum theorem. Triangle sum theorem is going to allow me to find the measure of angle C. Wait, why? Well, it's a triangle. We know all three angles, all three internal angles must sum to 180 degrees. And you already know two of them. So you'll simply add angle A plus angle B, subtract it from 180, and you get the measure of angle C. Guys, we have seen the triangle sum theorem show up in every single chapter since we were first introduced to it back in chapter 2 or chapter 3. We're now in our book, chapter 14. That's like 12 chapters now where you have seen the triangle sum theorem come out. You should be very, very good at it by now. Very good at it. So anyway, you're going to do the triangle sum theorem. You're going to add 25 plus 21.2, subtract from 180. Don't fat finger something on your calculator. You may not even need a calculator to do that. You'll wind up with 133.8 degrees. So, boom, we found the measure of angle C. Now I need to find the length of side C. You might be tempted to use the Pythagorean theorem. You would be wrong. Remember, the Pythagorean theorem only works if it's a right triangle. And I do not have a right triangle. 25 degrees, that's not 90. 21.2, that's not 90. 133.8, that's not, none of my angles are 90 degrees. So the Pythagorean theorem will not work. Your only option, the law of sines. So we'll do sine A over 21 equals sine, careful, I want to find side C. So if I'm trying to find side C, what angle do I have to take the sine of? Well, what's across from, I got to take the sine of angle C. At this point then, sorry, I apologize. I put a 21 in there and I should have put an A, side A. There we go. Plug and chug, we're going to solve for C. So we're going to have the sine of 25 over 21 is equal to the sine, big number, 133.8 over C. I apologize, I had to squeeze there. Let me go ahead and scooch a little bit so that it's not so... There we go. All right. I need to solve for C. Ooh, look at this. Let's cross multiply. I wind up with C times the sine of 25 is equal to 21 times the sine of 133.8. Awesome. In order to get C by itself, we'll divide by sine of 25. Let me scooch just a little bit more. There we go. C is equal to 21 times the sine of 133.8 degrees divided by the sine of 25 degrees. Feel free, you can put that in parentheses if you want to. You don't have to, but you certainly can. Anyway, it's now a calculator problem. Don't fat finger something. We're going to do sine of 133.8, multiply that by 21. Then you'll take whatever this number comes out to be and you'll divide by the sine of 25 and you wind up with 35.8, which is 36 inches. Sorry, that's a terrible approximately equal to sign. This is approximately, right? 35.8 inches, round at 36 inches. So anyway, there we go. We have now found absolutely everything. You found the measure of angle B. You found the measure of angle C, and we found the length of side C. You now know all of the measures in that triangle. You know all the angles, you know all the sides, and the law of sines helped us do it. So the whole point here to this section was we can solve triangles that don't have a right angle in them, and the way that we can do that based on the information you're given, it's very, very important that you either be given either an angle, side. Hang on, let's see if I can even remember them. So you either have to be given an angle, and a side. You have to be given an angle, side, angle, or the ambiguous case, side, side, angle, where you have to check to see if it's the ambiguous case. In whichever case you've got, the law of sines will help you solve triangles that don't have a right angle in them. I had a great time taking a look at the law of sines with you, and I'll see you next time.